Welcome to video 12 in a series of introductory videos for the InventorCAM CNC programming software. This video's topic is HSS Toolpath full version. So this will be the toolpath that you'll see with the 3D Pro or standard packages from InventorCAM. Essentially, this is the expanded version of the HSS toolpath. Previously, you would have seen in video 11 the standard or express versions of HSS. So this is just the follow-up to that. So to give you an idea as to what the difference between full and express HSS is, I have a toolpath on the side here. And these two surfaces right here. Originally, we would have used something like linear. So you'll see that parallel to the x-axis, we've got a toolpath that just kind of goes back and forth along those surfaces there. Now, at the edge here, I've actually left the link between slices that we would have seen in video 11. I've actually left those there just so we can see the major difference here in terms of the movements. So with a linear HSS toolpath, we're just going parallel to the x-axis or whichever line I choose, and we're trying to approximate that surface using that. So in a general sense, it's okay, but it's not exactly giving us the exact finish we're looking for. If I switch this to constant Z, it's the same sort of thing. Again, like we've seen in video 11, the step over is in the Z-axis, so we tend to get a little bit of fanning out as we go down this surface. Now, the same surface, I've actually programmed it using the options available in this full version of HSS. So let me open this up. We'll take a look at that before I actually show you the toolpath. So I'm calling this one Morph Between Boundary Curves. Essentially what I'm doing is under the Geometry section, we're still doing those same surfaces. This time, though, with the expanded HSS, we have the option of choosing contours or chains to better control the movement of the tool. So in this case, the toolpath is going to start on this chain, and as it goes along the surfaces that I selected under Drive Surface, it will morph to better match this chain. So essentially, with Morph Between Boundary Curves, I'm basically telling it to blend the toolpath between those two curves. The rest of this programs the same way as you would have programmed all the other toolpaths you would have seen in the HSS Express from video 11. We're choosing our tool, choosing our levels. In this case, levels in an HSS toolpath are just the clearance area. Toolpath parameters, we're going to be stepping along that surface by 20 thou. Link, same sort of thing, link between slices and whatnot. Now in this case, I haven't changed anything here again, so we can also see the differences between the linear, the constant Z, and now the Morph Between Boundary Curves as to how it handles that surface. So if I calculated that and take a look at the toolpath, we'll see that it now blends the toolpath across the surface. So what we're actually getting is blending along the curves, blending along the surface. This will result in a better finish on this surface. And once again, on the edges there, I haven't changed the link between slices. I could have actually cleaned that up. But you'll see that between the three types of toolpath, this will be the cleanest one. There's no linkage issues or anything like that. Because we're morphing, we're blending with the surface, we get a nice smooth toolpath almost automatically. Okay. In addition to that additional toolpath, what we also get is with our constant Z toolpath, we actually get the ability to do a spiral. So let me just open this up and I'll show you what I mean. So parallel cuts constant Z, like you would have seen in video 11. The geometry in this case is still just the drive surface, just a single one there. I'm just going to do that dish area right there. But the difference here is now under toolpath parameters, under sorting, in HSS Express, we would have just had one way or zigzag. But again, now that we're looking at the full HSS, we have a 3D option where we can choose spiral. So the cutting method is not just going to be one way or zigzag, it's actually going to progress in the Z direction. So again, if I calculated that, we'll see that we get a toolpath that basically, as it's doing the constant Z cut, I'm getting it to spiral down. It's not actually trying to do one pass, link down, do another pass. It's actually just trying to constantly move in the Z direction. And also what I've done here is I've blended a spline between the links and the gaps. So that's why this looks like a nice continuous toolpath. The additional options in HSS Full, again, they use contours to better dictate the path of the tool. So a good example would be these ones right here, where I am machining this surface right here. And under parallel to curves, I've chosen this curve on the bottom edge of that surface that I'd like to remain parallel to. So this may look similar to the linear toolpath, but what this actually allows you to do is just choose any type of curve, not necessarily a straight line. Here it happened to be a straight line, but you could choose any type of curve and you'll remain parallel to that curve. You'll morph a toolpath along the surface that remains parallel to that curve. So in this case, I've actually added my link between slices to make sure that it's smooth on all edges. So we get a nice linear looking toolpath, but essentially it is parallel to that bottom curve. This same surface using the option of perpendicular to curve, again, same surface, same contour, but now I'm telling it to generate a toolpath that is perpendicular to that curve. Once again, it's still just a straight line, but we get the idea that we can now make a toolpath perpendicular to that curve. So between these two, you should be able to choose a curve that gives you the toolpath you're looking for. You can think of these as the precursor to the morph between boundary curves. Under morph between boundary curves, we chose the start curve and the end curve, and we blend between the two. With parallel to curve or perpendicular to curve, essentially what we're asking InventorCAM to do is blend a toolpath that remains parallel or perpendicular to whichever curve we select. Finally, there is the option of the projection. So what this actually is, if I move this part around a little bit, is we're telling it to put a toolpath on these surfaces that is actually a spiral toolpath. You can see here, and we're going to project that spiral toolpath onto those surfaces. We'll start from a 0 radius, and we'll go as far out as I tell it to. Now, I've chosen spiral because it's the most cosmetic of them. It looks really nice when we generate it, but you have the ability to do a radial or an offset pattern. And again, we program it the exact same way. So if I generate this real quick, we'll see that from the top view, it looks like a complete spiral. I started from 0, and I morphed out to a radius of about 0.5657 inches. But if we angle this, we'll see that I've actually laid down that toolpath. So this is a fully 3D realized toolpath. We've taken a spiral and we've just draped it on the surfaces that we'd like to finish. So for full HSS, really all it is just a step up from the HSS Express. We've added some additional 3D options, additional controls over the path of the toolpath. Again, as a finishing toolpath, you really want to use these to get the best finish on your part. Any questions on this or anything else you see in the videos from this series, you can always call us at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos in this series. Thanks for watching.